Hello, my name is Chen Reuven. I'm a systems engineer from NetApp. Good afternoon, everyone. Sorry. So today we will talk about NetApp and our contribution and integration to OpenStack. So I don't sure if everyone knows who is NetApp, so I'll start to introduce what NetApp does in storage or in general. We'll talk about some basic terminology in storage and other things about NetApp, the NetApp portfolio, and the OpenStack integration. And if we will have enough time, we will see a demo, a recorded demo, which is taken from the OpenStack Summit, which took place in Boston. So NetApp is one of the global Fortune 500 with a revenue of above 6 billion revenue. We have around 12 employees around the world. We are the first market share in Israel and the second one worldwide. In Israel, we have 140% year-on-year growth. This year, it will be our 25th anniversary and the 20th anniversary in Israel. In addition, we were part of the Manila and Cinder project leaders. The Manila is the file services driver for OpenStack, and the Cinder is the block driver for OpenStack. Sorry, but nowadays we are consider ourselves as a data company. So it takes care for all the data services, the data management. We know how to protect the data. We know how to move the data, and to replicate it, of course, and to sync it to other places around the world. So for start, the basic terminology, we will talk about the data fabric. So NetApp is one of the founders of the data fabric, which means that we can leverage every place in the world in order to move the data, protect the data, and manage the data. So obviously we have our regular appliances, which I guess everyone is familiar with. We have the converged infrastructure, which means that we have solutions that pre-configured and includes servers, networking, and storage. As I said, it is a pre-configured, so you just plug and play it and use it in your on-premises data center, and it provides the configuration that you asked for. For example, if you asked for OpenStack environment or VMware environment, so it all will be pre-configured and ready to use as production. If you have non-storage systems such as EMC, IBM, HDS, for example, we can manage the data using flex array technology. So we can just map the LANs from the non-NetApp storage to our storage system, and we just manage it seamlessly as it was NetApp system. In addition to that, we can install on-top version of on VMware, which means that it is a fully virtualized NetApp system with all the on-top features and capabilities running on VMware, and on our roadmap is the KVM and OpenStack. And if we take one step forward, so we can manage the data even if it is not in our local on-premises infrastructure, which means that we have integration with our local service providers. We know how to replicate the data to them because they are based on NetApp infrastructures. So we can replicate the NetApp to NetApp replication to them. And at Amazon and Azure, we have a virtualized ONTAP running seamlessly on Azure infrastructure and Amazon. So we can get, again, a fully virtualized ONTAP system with all the features and capabilities inside Azure and Amazon. This is how we manage and protect the data everywhere. No matter where your data is located, we know how to replicate it, to move it between the clouds, to move it between the on-premises and the off-premises, to protect it and manage it with the same tools that you have on-premises. Okay, and when we take out data from our on-premises infrastructure, actually we're just creating a lot of data silos. And when we created data silos, we're just making ourselves an overhead, and it is much difficult to manage it when I create a lot of silos. This is not the same infrastructure, this is not the same management tools and capabilities that I know from the on-premises, and it's much difficult to protect the data, to move it around, and etc. So by implementing our data fabric vision, we can move the data, replicate it, manage it, protect it, and etc. with the same tools and features. So moving on for the storage terminology. So Snapshot is a full point-in-time copies. It enables us to create a lot of copies without consuming a lot of space. Actually, from the creation, it is 0 kilobyte consuming of storage space. We can create a lot of them. This is the fastest recovery solution that we can achieve because I never pull out the data from the storage system. I just create a full point in time with changes of the pointers itself. So it enables me to recover very, very fast from it, and it enables to create clones, very much clones from my data. And dedupe. Dedupe is our technology to identify identical blocks, to eliminate them, and by eliminating them, we can reduce the amount of physical storage space that we consume. So, about our portfolio. This is our major portfolio for the storage systems. We have the E and the EF series, which is a very cheap storage system with very high performance and low latency. It not include a lot of advanced storage features. It actually relies on the software itself. For example, Hadoop just use the storage from the E series and then creating the features from the software ability. The FAS and the AFF systems are very, this is our major selling product. So main thing that we can achieve is the data services, which means that we can replicate to the cloud, from the cloud, between clouds, and etc. It support multiple protocols such as NAS and SAN protocols, and it can scale out up to 24 nodes. And the SolidFire is zero-touch storage, cloud-like infrastructure. It can scale up to 100 nodes with guaranteed quality of service. We can achieve the minimum the minimum IOPS that we want to achieve, and the maximum and the best IOPS that we can offer to our application that use it. If I put it on a graph with, let's say, point of interest. So if I want to scale, and as I said before, to many petabytes and up to 100 nodes, so SolidFire will be the most suitable solution for this case. And I can guarantee I can guarantee performance by using quality of service. I can define minimum, maximum, and best IOPS for each application or each tenant that use or get storage services from the SolidFire. If I want to create a hybrid cloud solution with multiple services for block and file services, such as NFS, for example, or iSCSI, the ONTAP will be the most suitable solution because it can contain the replication to the cloud, fully virtualized instances in the cloud or on premises, and the E-Series if I would like to achieve only performance without any advanced features and rely on the software itself. In perspective of cloud integration, all of our products has cloud integration. For example, the E-series can back up directly to S3. The FAS and the FF, as you can see, has the most integration to the cloud. They can replicate to the cloud. We can tier to the cloud cold data. We identify cold data blocks, and we just tier them to the cloud. We can achieve dev and test in the cloud, which means that I can use the virtual instances for production users or dev and test, as I said, and we can back up to S3 as well. The SolidFire is, as I said, is already a cloud-like infrastructure, which means that it is fully automated via RESTful APIs, and it has also backup to S3. So if I map the drivers integration we have to our products, so the ONTAP supports all the protocols, Manila, Nova. Of course, I can run computes on the ONTAP, Cinder, Swift, and Glance. The ECUS support Nova, Cinder, Swift, and Glance. The storage grid and the AltaVolt I will not cover in this presentation, and the SolidFire also supports Cinder, as you can see, without Manila, Nova, and Glance. Okay, so why should I choose NetApp with OpenStack? So actually, service levels is one thing that we want to have when we are using storage services, because not all the workloads are the same. For example, I have a database that consumes a lot of IOPS and need to have low latency, and vice versa. I have a dev environment that don't need a lot of IOPS, or I don't want to allow low latency because it consumes other tenants in the systems. So by using NetApp, I can configure quality of services we spoke. I can configure minimum and maximum IOPS per application and burst per application. I can have a data protection configured. I can configure snapshots, a lot of snapshots to each volume inside the OpenStack. I can do a Vault replication in order to back up it to the cloud or to another NetApp system. I can create a lot of clones, and I will show you the times that we reduce by using our technology. So I can create a lot of clones for each environment or each VM that I use. Again, the replication, live migrations of VM, of course, and storage efficiencies, such as deduplication that I mentioned before, compression, data compaction, zero deduplication, and thin provision. These features are not available on every storage, and of course not on every application. So Cinder and Manila drivers, as I said before, Cinder is for block services and Manila is for file services. Both of them are developed with our contribution of NetApp, and these features are seamlessly enabled by using the drivers Manila and Cinder. I put some configuration that we can achieve, such as the RAID type. I would like that my production system will rely only on RAID DP, which is our protection against disk failures. I can configure the media type that I want to have, SSDs, SAS, nearline SAS, and etc. I can configure if I want to use thin provision or not, deduplication, quality of service, as we said before, compression, replication, and etc. And by configure these capabilities, I can configure SLAs. I can configure that my gold environment, for example, will have only RAID DP with SSDs and etc., or my bronze environment will not have replication or snapshots and etc. So let's take example of how I provision storage from AWS. I pay by provision IOPS or by the media type. So this is why I want to have differentiated SLAs for the storage. As I gave you the example earlier, database does not consume the same IOPS and doesn't need the same latency that our dev VM needed. And of course, Rackspace and every hyperscale service provider that we will show here will charge by the media type or by the IOPS that we consume. So the same in storage system, the same in environment that should provide everything as a service. For example, if I want to have IaaS, so every different storage service that I consume should have the different SLA that I want to achieve. So I will show you the demo. This demo is taken from the OpenStack Summit, which took place in Boston, as I said. I'll try to. So just a second.
So first, let's log in as administrator so we can create a volume type. So we go to the volume type screen, hit create volume type, and we create a new type, add a name, hit create, and that's it. We create a volume type, and we can proceed to create a volume using the type we just created. Now that we created a volume, we can create a snapshot of this volume. We give it a name and hit create a snapshot. Now that we create this snapshot, we can create a volume from this snapshot. There we go. We have a new volume from our snapshot. As you can see, that's very simple and straightforward. Now let's see how that is done in Manila. So in Manila, we can proceed to create a share type now in order to create our shares. And when we do so, we give it a name. And we have to specify the public S3 specs. Here, I'm going to say that I want snapshot support. We do this because we don't expect all storage vendors that have drivers in Manila to all support snapshots. We'll get in more detail in that in a few moments. So we create a share using the type we just created. Now we can create a snapshot of that share. And upon inspecting that snapshot, we see that's just a simple snapshot. It does not have an export location we can mount. If we inspect the share, we see that it was created without mountable snapshot support. The reason for this is that we also have to specify the public S3 spec for mountable snapshot support if you want to have this functionality for this set of shares. Again, not all backends support this semantic. Some support revert, some others support mountable, some support both. So that's how we use our public S3 specs mechanism in Manila. So now that we have created another share type and we specify that we want mountable snapshot support, we use it when creating another share. Now we create a snapshot. And now if we inspect this snapshot, we will see that it has an export location. If we inspect the share that we created, we will see that it has mountable snapshot support because we use a share type that specifies that in the S3 specs.
All right, so I'm going to relog in as a regular user. Obviously, to create types in both Cinder and Manila, you've got to be an admin. So I'm just going to go and run through the quick semantic creating from a snapshot. So I'll create a share. default type, pick my primary AZ. So this is what a normal tenant would see. Create a snapshot. And then starting with the snapshot, I can create a share. It's just that simple. So, of course, I can give it a name, a different type. But down at the bottom, the snapshot source is pre-filled in as the snapshot that we started with. All right, so now share 2 contains the contents of the share 1 snapshot. All right, so now let's move on to revert. So I could just create a share and a snapshot and revert to it, but that would be a little bit anticlimactic. So I wanted to have a little bit of fun and also include one of Manila's other advanced features. So Manila supports tenant-controlled replication of file shares. And so the rule is in Manila, if your driver supports snapshots and it supports replication, then it must also support replicating all of the snapshots of a replicated share to all of its replicas. All right, so we'll see that as part of this. So I'm going to create a share, pick my replicated type that I set up. And again, I'm going to choose my primary availability zone. So primary, in my case, this is my data center where I work. And so this share will be created on NetApp's ONTAP storage operating system. But this is a replicated share, so I'm going to go in and say manage replicas, because I want to create a replica. I need this to be highly available, so I'll say create replica. And there's only one choice here. So a little bit more background. I also set up an instance of Cloud ONTAP from NetApp, which is fully virtualized storage operating system running in Amazon, could also run in Azure. So I can choose the availability zone called AWS. And so if you think about it, wait a minute, this is pure Manila, and yet somehow I've overlapped OpenStack with Amazon. So I can only afford one data center, but I can have the same storage and replicate out to a completely different cloud. It's a cost-saving measure. But also, it opens up some interesting use cases of being able to do migration of applications and their storage between very different clouds. So anyway, enough of that. Back to revert. So my replica starts out as out of sync. Within a few seconds, it'll become in sync. Okay, and so now I've got the same copies, 2 replicas of this share at different sites. All right. So now I'm going to go and create a couple of snapshots. So creating a snapshot of a replicated share takes a little bit longer because Manila has to make sure that snapshot is replicated to multiple locations. Right. Create another snapshot. Creating 2 so that you can see Manila applying the rules for revert. So I have 2 replicated snapshots. Go back to the share, and I can say revert share. So there's a pop-up here, but Manila is only giving me one choice because it knows that Snap 2 is the most recent one known to Manila. If I wanted to revert to Snap 1, I would have to delete Snap 2 first. Okay, so the status transitions through reverting back to available, and the revert is complete. It should be an instantaneous operation.
So the idea was to show you that we have fully integrating to OpenStack via Manila and Cinder. So this is how we can manage, sorry, just a second. This is how we can manage and integrating NetApp storage to OpenStack in order to create snapshots, clones, replicas, and etc. And to save all of our abilities and features no matter where the data is located. So about the time that it took, let's see some examples between our competitor and using ONTAP. So clone 1,000 volume of 100 gigabyte took the competitor 15 minutes, and we only took 5.7 minutes. So we can see the times. For example, this one, the boot 1,000 new persistent instances of 100 gigabyte, took 150 minutes, and we only took 26 minutes. So by leveraging our technologies, we can do more with less time, with less capacity, with less storage, physical storage needed. And for more information, you can check our GitHub on netapp.io, and we have all of our integration APIs and documentation about our integration to OpenStack and for Dockers as well. We have a native plugin for Docker containers, which you can manage the NetApp services. For example, we use the Docker volume create, the regular volume create command from the Docker host in order to create file services from the NetApp, and the NetApp driver will provision the storage, of course, and mount it to the Docker containers seamlessly without knowing even that it is NetApp. So that's all. Thank you very much.